A 20-foot ladder is leaning against the wall. The base of a ladder is sliding away from the wall at a rate of 2 feet per second. How fast is the top of the ladder sliding down the wall when the base of the ladder is 12 feet away from the wall? All right, so this is a related rates problem, and this is a calculator problem, but I'm not convinced we're going to need the calculator. Maybe we will, maybe we won't. Let's draw a picture and let's draw what we know. Okay, that is an awful triangle, but leave me alone. This is the wall. I'll call it W. This is the base, I'll call that B, and this would be the ladder leaning up against it. We'll call it L. Okay, what I know is that the ladder is definitely 20 no matter what. I know that this is a right triangle. Okay, what I also know is at the moment the base of the ladder is 12 feet away from the wall. So this is always going to be changing, but at this very moment we have 12. What I don't know then is at the very moment, where is the ladder leaning up against the wall? So what we need to do is we need to find out that W, and we're going to use Pythagorean theorem to do it. 12 squared plus W squared equals 20 squared. 12 squared is 144 plus W squared equals 400. Subtract 144 from both sides. That gets us W squared equals 256. Square root both sides. You don't need to positive or negative anything because this is going to be distance. And the width at that moment is going to be 16. So you're 16. Now, in order to do the related rates problem, we need to realize what is changing and what's not changing. We're going to reuse this equation, but not do too much. The ladder is always going to stay 20. Okay, where my base is and where it changes versus where the wall is and where that changes is always changing. So the related rates problem that I'm going to write out is going to be the base squared plus W squared is going to equal 20 squared. Okay, now what we're going to do is we're going to ddt both sides. Take the derivative with respect to time. So ddt, ddt. That leaves us with the derivative of b squared, which is 2b, with respect to t is db dt, plus the derivative of w squared is going to be 2w dw dt. That's going to equal 0, because the derivative of a number is 0. Okay? So let's plug in what I know and what I don't know. I now know that b is 12, so 2 times 12. db dt is the top of the ladder sliding on the wall, the base of the ladder is 12, because the base of the ladder is, no it's not, it's, what is it? It's sliding away from the wall at 2 feet per second. So db dt is 2, because it's 2 feet per second. Okay, that's going to be plus 2 times w, which is 16. dw dt is what I'm trying to find. That's going to equal 0. So let's write this all up here. 2 times 12 times 2 is 4 times 12, which is 48. Plus 2 times 16 is 32. dw dt equals 0. Let's subtract 48. Let's subtract 48. 32 dw dt is going to be negative 48. Divide both sides by 32. Divide both sides by 32 is dw dt equals negative 1.5. Why negative? Because it's sliding downward. So negative 1.5 is going to match up with 1.5. And that's how you do that problem. No calculator needed. You could have used a calculator, I guess, but not needed.